So in this video, we're gonna uh, discuss a little bit about the functional programming with R. So a lot of people say that R scripts look like a list of commands, and there's not much programming in it. Um, but if you look at the functional programming aspects of R, actually, R does have such facilities, uh, and some of the methods could be useful for programming. So to write a function of in R, basically you just assign something as a function of x. For example, I assign fx is x squared, and now in my environment, I got this function, and there you could see its interior, and you could like in the other videos I said, you could do a bunch of things. Like you could see it's the body of the function. It's s squared, and the argument of the function is x. What's important here is that you could actually turn that into expressions. So if I go s expression body of f, I got this expression x squared. So what is important? So a language is a system that parses certain things and probably deparse certain things and then evaluate them. So when we talk about evaluation, if we just put x equals to 2 there, and I put s squared, and I got the answer. But for fx, if we put x equals to 2 in that closure, I also get the answer. What's important about the expression, if I name that f expression, sorry, I can actually evaluate them by using the eval function. So now I get those f express function here, and also I got 4. But if I say evaluate an expression, and this expression assign x equal to 39, say, and then so this thing doesn't necessarily change x value in the global environment, but what if I do let's say x is 39. I just directly put x equals to, sorry, 39 here, and also I put the f expression. So this is actually parsing, not parsing, just evaluating these expression and to tell you the value of the f expression in this closure is 1521. But this isn't actually a very useful or very recommended way of doing this. But if I get a certain character, say 1 plus 1, I probably load these vectors from some data files, or no matter where that is. So if I take that would just store as a character, and I could use this expression to assign some the character value. So a is an object and a string containing 1 plus 1. But what if I want to evaluate a? So I could create an expression by using parse text. Text is a. So now this turns the text you are input into the function to an expression that you could actually evaluate. So if you want to evaluate that, and just say whatever you want. So you might be asking, why is this evaluation useful? Now, if one example is of the symbolic calculation. We could turn some functions into the form of expressions and actually differentiate that. Like, say I want to use the function. Sorry, is it called derive? Oh, sorry. With respect to x. Now it's telling you that the derivative of this expression is 2 times x. Now, you can also, there's also some way to convert that back to the normal form, but we'll talk about it later. And usually the people don't really use those default symbolic thing in R by using some package like non-derive or Ryakas, or something like rSymPy, or just like that. So what is the structure of a function? To say, and I can actually see its attributes. So there are different ways of defining functions within R, but if I go F2, so here I got another function which it's actually also a symbolic function, but unlike that, I'm putting x squared to it, and then F2. If I put 2, I actually also get the same answer. But what's happening here is that its body contains some extra parts, and so you want to avoid that when you're doing a simple symbolic calculation, or you're writing simple numerical functions, because that makes it slow and make it the string processing quite difficult. But I hope the first part gives you an idea that the functions are essentially stored as a sort of data, and the function. So if they are stored as data, then the function can take functions. Could possibly take function. I know that's called take functions. I know that's sometimes not valid in C or there's some other language, but if you have a look at the Lisp or some functions, some programming language of functional programming, this could be actually very useful. And when we're talking about those parsing, how to parsing the file, you could of course create write a temporary R file and source that R file. So you're using R to write R in some ways. Right. Let's just this. Another case is the deparse file. So unlike I want to evaluate that, I want to convert some variables into its original, to its name, and I want to get a name of one certain thing, and then if I use the deparse A, it's actually taking the contents of A and deparse the 1 plus 1. But if I deparse substitute of a, then what's going to happen is that it's returning a character of the name of the object, which if you write some kind of so to get an idea how this is used, let's just plot some iris thing. So iris is so probably everybody knows this example, but say iris is it's a data frame, but it's actually taking those separated values into that and using those name of the variables to output on these things. So in some cases there should be some processing of strings, and if I go attach and or is it load and sorry just attach, and then I plot the sample length with respect of petal length, and actually it's kind of hard to get those values, and if you see plot vector, sorry, isn't plot numeric. So it's in some cases it's useful to get those the name of the variable as well as a kind of input. So I'm putting one thing here, but I'm not only getting those values for its those data, but also its original name of it. So that could be used to represent something. So that's the first part of our functional structure. All right, see you in the next video.